record this. So basically, you can use this website, Random Nerds tutorial, to refer the information about the pin configuration and the pins, each pins like features of those pins, the functions of each of those pins. So the chip and its pins are given in this figure. So basically, there are ground pins. There are multiple ground pins which are available, and input voltage pins. And so input voltage pin is given as V in. So there's a 3.3 volt pin which can be used to obtain certain output. So this pin will be able to give a voltage of between 0 to 3.3 volts. You can refer those details for more details in the data sheet. The correct details, I mean, are always there in the data sheet. So when you are working with this 32 controller, you can you can check whether this pin is an output voltage pin, and then you can measure the output voltages through that pin. So the V input pin or the input voltage pin is a separate, it's separately located, and it is out in here. So voltage input, you can give it to this pin, and you can give up to a certain range that to a certain range. So that range of voltage that is allowed is also given in the data sheet. In general, it is like considered that for ESP32, it's going to be about like you can provide voltages up to about 5 volts, and you can do the functions in the microcontroller without any damage. So the limits of those voltage values are really important. So if you don't follow those limits, then the circuit in the microcontroller will burn. So in that case, it's necessary to maintain the correct voltage ranges. Otherwise, like, we might not be able to use the controllers. So so basically, apart from that, we have other types of pins. Other types of pins, as we discussed, it's like input output pins, and other types of pins like special pins are there. So we will discuss about those pins as well as a continuation of the last class. So also, apart from the voltage values, maximum voltage outputs and voltage inputs, we also have maximum current values defined for the system as output current, and maximum output current could be in the range of milliamperes to about 1 ampere range. So the output current can be in the milliampere and ampere range. So you can obtain up to 1 amperes of current from this controller. So those details are also available in the data sheet for you to refer. So we have like the data sheet available in the LMS as well. So in the LMS, you can get the data sheet. The LMS, I have given the data sheet in here in the week number 2. You can refer that document. So in this document, almost all the details that you want regarding the voltages, the currents, and the functions of each pin are given. So if you want to go to any section, you can go and you can find the functions of each of the pins. So those details are given in these sections. So apart from all these pin functions, we have other, separate pins. As you are able to see, like as I said that there are input-output pins, which are also known as GPIO, general purpose input-output pins. And those pins are also having different functions. And it is also needed to like mention that there are, pins which are allocated for SPI communication, right? SPI or serial peripheral interface communication. So these SPI integrated pins are used for serial peripheral interface based communication. And for those kind of communication, these pins are allocated for that communication. So these specific pins are allocated for SPI based communication. The SPI based communication needs several pins to enable its communication. So for example, like the clock frequency or the clock input is given through a certain pin, and then data is given through another pin. Likewise, it requires several pins at the same time to be connected to the other device with which the ESP32 controller is doing the communication. So with respect to SPI communication, we need this set of all the communication pins to do the communication. So when we talk about the other types of communication, there are other types of communication methods apart from SPI, which are like UART, UART communication. So the UART communication or universal autonomous, we will check that UART communication. This UART communication. It stands for Universal Asynchronous Receiver and Transmitter. So UART communication or Universal Asynchronous Receiver Transmitter Protocol based communication is also enabled in this ESP microcontroller. In the UART communication, however, like it doesn't need multiple pins to enable its communication, according to my knowledge, and it needs only one pin allocated for the UART communication, and it is enough for it to communicate with the other device. So what I mean is that if you have SPI communication, you need multiple pins. So SPI communication requires multiple pins in the ESP32 microcontroller, and these pins are connected to another set of pins in another, let's say another device. If it is another ESP32, then it will use the kind of like, all these pins will be connected to the other pins of the other device to do the SPI based communication. So these pins have to be correctly connected. The one which is suitable need to be connected. So set of pins need to be connected to the to another set of pins that are corresponding pins, and those so the pins have to collection of pins have to be connected to another collection of pins in another ESP32. So so for SPI communication, we need a connection like this. And for UART communication, most of the time you can do the communication with only one pin, one UART pin, and you can communicate with using the UART communication. So Universal Asynchronous Receiver Transmitter Protocol. So UART communication is Universal Asynchronous Receiver Transmitter Receiver. Receiver Transmitter Protocol. receiver transmitter protocol. So this protocol is used to communicate with another device, and according to my knowledge, only one pin is needed for that communication to be established between the two devices. For the SPI, of course, we need a set of pins for the communication to happen between the two devices. And if there are, there are other communication protocols as well, such as I2C, I2C, I2C protocol. So even that requires uh, multiple pins to function. That all those details can be seen in the data sheet, and the data sheet will mention exactly the pins which are allocated for the I2C communication. So in here we can also consider the fact that I2C also requires the multiple pins to communicate with another device. So the communication using I2C protocol requires multiple pins. So those pins need to be correctly connected with the other corresponding pin in the other device in order for the data to transfer reliably from one device to the other device. So basically, we have uh, we have when we take the overall summary, we can take there are basically 18 ADC channels, or analog to digital converting channels. So you can input analog signals to these 18 channels or 18 pins. You can and get a digital output from those inputs and work with digital information in the controller. Also, we have 3 SPI interfaces. So we are able to have communication with three, we have 3 SPI communication interfaces, which allows communication to happen in the SPI protocol, and 3 UART interfaces. So UART communication is enabled, and there are 3 interfaces that allow that communication to happen, and 2 I2C interfaces. So I2C communication is also another protocol, which is another protocol, communication protocol, that is used to communicate between 2 devices. And the I2C communication refers to integrated inter-integrated circuit protocol. So I2C stands for inter-integrated circuit protocol. Integrated circuit protocol. So this protocol also requires multiple pins for it to function. So when we go and select these interfaces, we can check how this protocol functions. And if that protocol uses multiple inputs, and then we need, so it needs multiple pins, SDA pin and SCL pin, which are used to transfer the information of the clock signal and also the data signal. So the clock signal is required for the communication to be synchronous, right? Clock signal is given as an input in this communication in order to maintain the synchronous nature of the data communication and obtain the data in a synchronous manner at the other device. So when we are using 2 devices to communicate, one device will send the clock signal along with the data signal. So data signal will be applied to one port, other clock signal will be applied to another port. So the clock signal enables the data to be synchronized at the receiver end. So using the clock signal, the receiver will understand what is the data, and at what point we need to consider the data, the data packet or like the data frames. So these two pins are basically used for I2C communication. So therefore, we need at least two pins to establish the I2C communication. So likewise, we can go and we can search about each of these, interfaces that are used in the ESP32, and we can see that there are different interfaces for different functions, and basically SPI, UART, I2C are basically interfaces that are used to communicate with one device to another device. So these interfaces are used by the controller to send and receive information from another device. It could be another microcontroller. Also, we have PWM output channels. That means that we have pins, or we have set of pins that gives us this PWM, or we call that phase pulse width modulator signals. So pulse width modulator signals are known as PWM signals. Pulse width modulator signals. Pulse width modulator signals are known as PWM signals. And the ESP32 is also able to provide the PWM signals as well. So PWM signals are also, used in multiple applications, such as, controlling motors, right? Controlling motors. So likewise, in power systems, pulse width modulated signals can be used. So in those cases, in order for us to have the necessary performance, where in the power systems, we expect to reduce the noise and increase the signal power. So PWM signals can enable us to do that. So PWM signals can be generated from the ESP32 microcontroller. So that is another feature of the ESP32. Apart from that, ESP32 also provides the digital to analog converting pins, where we have digital input to the microcontroller, and the microcontroller generates an analog signal within the controller unit. Apart from that, we have so therefore, this ESP32 has both the ADC and the DAC communication channels. So the ESP32 is able to do both the analog to digital conversion and also digital to analog conversions. So analog to digital means, like, normally we provide analog signals as inputs. So the system microcontroller will do the digital, transformation part. It will do the sampling, quantization, filtering, all those things the ESP32 will do. So after that, it will obtain the digital signal of the analog input. So if the controller is given an digital signal, it also has several pins to convert the digital signal into analog signal. So the analog signal also can be generated in the ESP32. So as per the information, there are many analog to digital pins than digital to analog pins. So only about 2 pins are there for digital to analog conversion, but there are about 16 pins for analog to digital conversion. Sorry, 18 pins for analog to digital conversion. So there are many ports that are having the DAC or an ADC component, right? So ADC pins are there, more pins are there than DAC pins or DAC pins. So that is how the analog and input pins are defined. Then also we have another feature, which is the capacitive sensitive GPIOs. So I forgot about this I2S interfaces. this enables communication of, audio signals, as I remember. So it's also another communication protocol that is used for communication between two, devices. It actually uses much more, uh, I think, features than the normal other communication protocols that I mentioned here. So I2S interface is another communication protocol that is used, and I2S, yeah, 2S communication protocol is basically used for communication digital audio data. As I mentioned also about audio data transmission. Um, so I2S is used for serial communication of audio data between two ICs. So I2S is a communication protocol that is specifically useful for audio data transfers between the two devices. And then we have touch pins, so capacitive sensitive pins, which we call as touch pins. And touch pins are basically a special feature of this ESP32. The ESP32 has this special feature which is not available in the Node MCU. So Node MCU is another similar microcontroller which was also manufactured by the same, before the CSP series, and that microcontroller do not have this, sensor, touch sensors or touch sensor pins. So these touch sensor pins are basically working in a way that once we connect a wire and then we give a certain touch or certain voltage, then the output of these touch sensor pins will change from one state to another. So it is useful for situations where we use touch pads or some kind of touch devices as the input. So the touch pins are useful for applications where we are using the ESP32 for touch based device connections. So we have the ESP32. We have basically several touch pins, and these touch pins can be connected to touch pads or other devices which work on sensing, touch sensing. And then these touch pads can be connected to the ESP32. So touch pads can be used in for different applications. So if you have touch sensitive applications, then you can give an output based on your touch to the ESP32, and based on the output, the ESP32 can be controlled to do some kind of function. So we can program it based on the input that we received through the, for example, through the touch pins. We can program the ESP32 based on the inputs that we receive in the touch pins. So the touch pins are special features of the ESP32. So those are one of the information regarding the pins of the ESP32. So other things are such as like the clock frequency. The clock frequency of the yes.
Means what kind of sensors are connected to that audio signal pins?
So audio signal means like digital audio signal pins. So like if you, you can record some audio data and then you need to actually convert it into digital data through a certain, ADC, and then you want to connect it to the I2. Then you need to connect that data from that certain controller to the other controller using the I2S interface. The I2S interface is taking input of digital audio data. So digital audio data means like you're um, you're having normally audio is in analog form. So that means like any say, music video or music song, any kind of song, you can take convert it into digital format. So this kind of, I mean, audio data is actually what we consider as audio signal, or else we can actually record the sounds in the environment, record or take the sensors and I mean, let's say it's a mic. You can take a mic and you uh, record the surrounding sounds, right? You can use a mic and you can record the surrounding sounds. So that signal you need to convert into digital signal, and that digital signal need to be fed into this. I mean, the digital signal need to be created in the ESP32, and the ESP32 has to transfer that audio data from one controller to another controller. So that once you're sending that audio data, that data will be sent through the I2S interface. So basically, like audio signals contain a lot of data. So these audio signals has to be processed very quickly. So the I2S interface, as my knowledge, I think you need this I2S interface to do the processing more faster, in a more faster manner. So is it okay?
Okay, thank you, Miss.
So you so we were talking about the clock frequency. The clock frequency is the frequency that is generated by the external oscillator in the ESP32 microcontroller. So in the microcontroller, there are internal and external oscillators, and we have the external oscillator frequency that is mentioned as so we have a chip. So we have external oscillator here somewhere, and that external oscillator can produce a clock frequency of about 40 megahertz. About 40 megahertz of clock frequency it can create. This clock frequency affects the data processing speed of the controller. So although the external oscillator is about 40 megahertz, the clock frequency actually, or the actual final clock frequency of the ESP32 is determined by the internal oscillators. So there are like two oscillator types. So external oscillator, and we will take internal oscillator as the oscillator inside the controller board. So there are other like circuits that enhance the clock frequency produced by the external oscillator. So external oscillator has the 40 megahertz frequency, but that frequency is further enhanced through another internal circuit in the microcontroller board, and that internal circuit increases the clock frequency further than 40 megahertz. So from 40 megahertz up to 80 megahertz, the clock frequency is increased. Clock frequency of ESP32 is about in the range of 80 to 160 megahertz range. ESP32 can therefore do like data processing of about megahertz with megahertz frequency. That level of processing is enabled through this clock frequency. So the clock frequency impacts the amount of data that you can process at a certain time instance. So data that you can process at a certain time instance is determined through this clock frequency. So the data rate or data processing rate is defined by that frequency. So ESP32 has about 80 to 160 amount of megahertz frequency, and therefore it can process megabits or megabits of data per second. Megabits of data per second it can process, and therefore per second it can process mega range of data. So it is a large amount of data. So therefore ESP32 is considered considerably efficient microcontroller. With the other thing is that so the clock frequency is determine the data processing rate. Another features if we talk about the ESP32 will be its functionality in terms of communication. So ESP32 has multiple communication technologies enabled. So it has it supports Wi-Fi, it supports Bluetooth, and when you consider about the Wi-Fi, it has many functionalities. So ESP32, when you consider about the Wi-Fi functionalities will be such a way that it supports Wi-Fi protocols of 802.11. 802.11 means the standard protocol of Wi-Fi. Under Wi-Fi, we have different variations. We have the B variation 802.11b. We also have G 802.11g and 802.11.n BGN we can call. So there are three standards there itself. So these protocols are defined for different frequency bands and data rates. So 802.11b and 802.11g, 802.11n, these protocols are defined for certain data rates and certain frequency bands. So in standards, you don't have to remember these numbers. So what I want to say is that this 802, this standard B, 802.11b standard stands for communication that is done in the frequency range of 2.4 gigahertz. Though the difference, so 2.4 gigahertz, and in the standard G, it's also using the 2.4 gigahertz frequency band. The difference in here is that the data rate of the standard G is much more higher than standard B. So the data range here is megabits per second. And for data rate under G standard is about 54 megabits per second. And when we take the N standard, it can work with both 2.4 and 5 gigahertz. And that has a data rate of 450 megabits per second. It has the highest data rate. So the N standard. All these Wi-Fi protocols are supported in the ESP32, and therefore we can reach the Wi-Fi connectivity and do a lot of applications because of that feature. So although ESP32 is kind of inexpensive, or it is not that expensive, even in Sri Lanka, we can buy this ESP32 for amount of more below like 2,500. We can buy the normal ESP32 for amount of 2,500, and it's a considerably lower amount when you compare with the other microcontrollers such as Raspberry Pi, which are more advanced and has more features. The ESP32, however, although it doesn't have like Raspberry Pi's performance, it is able to provide the Wi-Fi connectivity, Bluetooth connectivity, which are also very important, communication aspects, and which gives this microcontroller a very good demand. So ESP32 can be used to connect Wi-Fi, which allows a lot of applications to be generated. So in general, ESP32 works with 2.4 gigahertz basically, and can reach data rates of about 100 megabits per second. When we talk about the other connectivity methods, we have Bluetooth connectivity also enabled in the ESP32. So it can connect via Bluetooth to another device. Apart from that, when we talk about the Wi-Fi only, we will talk about the Wi-Fi only for the moment. The transmit power of the Wi-Fi signal can also be changed, right? Transmit power of the output RF signal, transmit power of the RF or radio frequency signal can be adjusted, can be set to the maximum, and can be adjusted as we prefer. So we can set it to a value of 20 dBm, right, which is about 100 megawatts. Milliwatts. 100 milliwatts. We can reach 100 milliwatts transmission power, and we can control that transmit power of the signal, and therefore it is also another interesting feature. So we can transmit the radio signal with the transmit power that we prefer. We can control the transmit power. Another thing is that this ESP32 can work or act as an access point, a Wi-Fi access point. ESP32 can act as an access point, Wi-Fi access point, and therefore, like, it can create its own Wi-Fi hotspot. But it can create its own Wi-Fi network. It can create a hotspot on its own and give the connection to other devices. So those are one of the main features of the ESP32, and specifically about the ESP32's Wi-Fi capabilities. So do you have any questions?
No.
Okay, so I think that those introductions will be sufficient for you to get an initial familiarity with the ESP32. So apart from that, if you can purchase ESP32, then we can actually start doing the coding on the ESP32 and develop our own applications there. So if you can then try to install the IDE that is necessary for the code development, then we can develop the code in that IDE or the development board, the development interface. So IDE, yeah. So in that you can develop your code. So you can search about the different IDs that are available, MicroPython IDs in this website itself. So so these are the IDs that are popularly used, um, and uh, you can use any of those IDEs. And for the project also, you can use any of these IDEs. It's okay that you don't use the Upycraft IDE, although I have specifically mentioned that in that instruction sheet of doing the project. You can use any of these IDEs. So these IDEs are actually MicroPython based IDEs. If you want, you can like check about the C++ integration into this. So VS Code, as you mentioned, you can use C++ programming in there with the necessary extensions, and then you can integrate that with the ESP32. Other editors such as Mu editor, Upycraft editor. So those things also like they are working with MicroPython anyway, and then you can connect these IDEs to ESP32, and you can see whether you can run sample codes in the IDE. So like when you take about the Upycraft IDE, you need to follow these steps to set up the IDE. So first of all, now we need to install the Upycraft IDE. The Upycraft IDE looks like this. It's not that I mean, it's not. Maybe some of you might not like it. So if you want to install it, you need to go to the website, to their website, and download the setup file. So I mean, you can find the downloading files, right? You can find where you can download it. So you can go to the pages that are having that information. So so basically you can install it on Windows, Mac or Linux operating systems, and uh, you can actually follow the necessary steps to install it. So when you're installing, this mentions that you need the Python. So if you don't have Python, you need to first install whatever the latest version of Python, and then you will be able to, I mean, after you finalize the Python installation after this point, then you can, after you finalize the installation, then you can download the Upycraft IDE. So that IDE installation, I mean, that link is also given in that website. So you can download it. You can download the setup, and you can run the setup, and you will be finally able to get an interface like this. So I will run my one. So this Upycraft interface looks like this. So I need to connect my ESP32 to this ES interface to see outputs. So I need to check whether the sample codes are working, and then I can ensure that the controller is connected properly to the IDE. So before connecting and like trying out the sample codes, we need to first set up the IDE. So there's a separate operation you need to do. You need to first flash the MicroPython into the firmware, or in the hardware of the ESP32. So you need to install the MicroPython. You need to install the MicroPython in the ESP32 ESP32 microcontroller. So this is the kind of instructions that you need to follow to do that. So first of all, you need to, go to the IDE. You need to follow the, go to tools, and then in there you have an option called burn firmware. The burn firmware, you have to select specific parameters in here. So the board is ESP32, it's ESP32. Then burn address, you can select to up to 0 into 1000, and then erase the flash or erase what is already there in the ESP32. And then you can set these settings as these are the default settings you need to use to burn the firmware. And then you can actually once you connect your ESP32, you can see a port available in here. You have to select the port, and then here you have a specific file that you need to upload in here. You have to select users. You have to upload a specific file in here. Those details you also need to refer in this website as well. So in here, that file that you need to upload there can be found. That file is a bin file, and it is available in the MicroPython downloads page. You have to get the latest bin file there. So once you are connecting the ESP32 to the IDE, you will be able to see the port, the relevant port of the IDE. Relevant port which is getting connected to the ESP32. So you need to get that port mentioned in there. Otherwise, you cannot actually, you cannot really, do the communication properly. So we will see whether it appears in my computer as well. So I will connect my ESP32 and we'll see whether the port is appearing. Most of also we have to check the device manager. If we cannot obtain a port in here, then we need to set up and see whether the port is enabled in the device manager. In the device manager, you can see in under ports, different ports that are already defined. So in the ports in here, you can see in here it is mentioned that the COM5 port is already defined in the under the ports, which means that COM5 is something that is recognized in the computer. So the COM5 serial port must be selected in order to do the communication. Now we can do the burn firmware part. In here I can select this and I can select yes. Then erase flash. Then I can select the bin file that I want to import in here, upload in here, and I can go to that file through this MicroPython downloads page. The MicroPython, that page doesn't have anything at the moment. Maybe you need to go to the other page. So we have to go to the correct page. So this correct page looks like this, and you can go down. You will see there are multiple microcontrollers available, and you will be able to select your own microcontroller. In here, we will select this one, which is ESP32W Room Expressive. In there, you can see now this is the one that I have with the ESP W Room 32, right? So that is the model of the chip. So and then you can go down and you can see like what is the latest bin file available. latest bin file I will download and I will keep it in the desktop or somewhere that I can access. And then I go back to the IDE. In here, I need to install, I need to put that file in here. So the file that I downloaded earlier is in here, right? So I import it in here, then I put OK. Then once the flashing is done, it will be shown like this. It will have a certain progress, and you will be able to see that in this bar. So after you have installed those things, now I think you are ready to check out the sample codes available in the IDE. So we have sample codes available in the IDE, and they are available in the file examples tab. So I think now flashing has been completed. Okay. So then you will be having this IDE. So this IDE has different, sections. So first section where you have the directory of all the files that you can access. And then you have this, space in here where you can write the codes and you can implement the coding part in this part. And then you can see the output in the down bottom part. Apart from that, in this section on the right hand side, you can see that there are options to like save the files, run the files, connect the file, connect the terminal, and so on. So we have to see whether we can connect the board to this IDE. So we will check that, right? So there's some kind of error coming. So either something has gone wrong. We can see whether now this is the sample code, right? The sample code. So I'm sure that now this is the sample code which I got from file examples basic blink. The blink file is the most basic sample code that we can write. So now we want to see, now they are saying COM5 port is not open or it is not allowing the communication. We need to just check whether COM5 is available, and then whether any other work needs to be done. So we can check whether, we can check, try to click this multiple times. Like it takes some time for the whatever the initial configurations to happen. So we can check by clicking this, and we can click again. And then once you if you have this sign coming, that means that it is ready to receive a code. So now we can run this and see. We will run using this function. So if I don't know, like in my ESP32 microcontroller, I'm able to like actually get the blinking working. So I will try to, I have connected the works, board. So I don't know whether I can show it. I think my I need to reverse. So I will be able to show you this blinking function, and this is just the basic blinking operation. And then you can test this out and you can see this as well. And it is the basic thing you need to check once you have the IDE. And that means you can develop and you can run the codes in the ESP32. If you want to stop the code, you can stop using this function. And once you stop, I can see that the code has, the blinking has stopped. Now the blinking is not there anymore. So blinking stops once you select the stop function. All the functions are here: run function, stop function, connect function. So you can try out sample codes on your own and try to get the code working. So that is basically regarding ESP32. Do you have any questions to ask? So there are some error messages that you can get. So you can check these troubleshooting methods to overcome such error messages. So that is basically regarding ESP32 microcontroller and how to set it up with your IDE. So apart from that, next we have to learn about the sensors that we can connect to the ESP32. And one such sensor is the ultrasonic sensor. So we will discuss about the ultrasonic sensor, I think, in the next class. So I will discuss about the assignments that are due now, I think. Do you have the access to the attendance monitoring tool?
No, miss.
You already sent an email as well, right? I think you have sent an email regarding that, right? Requesting them
Yes.
to send access. Are you not able to access that tool anymore?
No, miss. Not still.
Okay, so that means that it's unable for me to also like show that I'm actually conducting the class for you. So it's not possible for you to kind of enter this area, right?
Yes.
So I will anyway create a session and then I will just keep it open. If you are able, I don't know whether you are able, but anyway, I will just create it because I think I need to share it. So whatever the think you cannot, yeah, I hope you can see it. So okay, when we talk about the assignments in the IoT section, you have the IoT project that is something that I discussed with you in the last class. So so I will assign you a separate link to submit your projects to the LMS. I will assign you a separate deadline as well. I will give you maybe 2 weeks more than this deadline. Is it okay with you? So I think we started these lectures after maybe 4 5 weeks of, yeah, after 4 weeks. So I will add 4 weeks to you, maybe 1 month. And then I will give the deadline as February 15th. Of course, if it is okay with you, let me know. You're not okay, then let me know. So the interactive sessions I have done and the assignments that I have given the other students, I will also allocate to you, and I will provide a separate link to submit those assignments. So the first assignment that I have given is this one. So the first assignment is about choosing. Is about taking a certain IoT product and then pointing out the components of those IoT product. Um, Basically, there are main components in an IoT product, such as the sensing unit, uh, processing unit, storage unit, communication unit, power unit. So these units are most of the time available in any IoT device. So you need to mention, like, you need to label those components that are visible in a certain IoT device. You can take a certain IoT device, you can check the inner components, an image of, you can take image of inner components, or you can take it from the internet. It is totally fine. Then you can label the separate units that I mentioned here mainly. So if they are having sensing unit, you can mention that. Likewise, you can mention the components that you can basically see in the IoT devices. So that would be one of the submissions. Second example was about the ultrasonic sensor and using ultrasonic sensor to take distance measurements. So this is also another assignment that I will be assigning to you as well. So I will, I will give that assignment, and you need to do that using the ultrasonic sensors. So for this assignment, you need the ultrasonic sensor, ESP32, and a certain IDE. You need those components to do this assignment. Also, I am allowing you to do the projects or assignment with a group. You can get together with your friends and then you can do this assignment. However, you need to submit a unique report on your own when you're submitting. Although you are doing a group project, you have to have your own unique text in the report. You can have the same images, but the text that you write must be unique to you. After that, I have given another assignment lately regarding ESP now protocol, which I covered lately, recently. And those are the three basic assignments that are due. So I will assign you to do the first assignment, and I will give us a separate link for that, and so you can complete that. The project, of course, you need to you can do with the group, and if you are doing with the group, you need to mention in here what is your group, and you need to mention the member details in here. If possible, you can enter those data in the lateral entry sheet. There's one sheet for regular students. So that is all that I wanted to basically discuss regarding the assignments. In this up to now today in the lecture, I have discussed with you about the interactive activities I have done. In the IoT module. So in the last class, in the theory section, I have discussed about the introduction of IoT and about the components of an IoT network. So in the in this class, we can actually discuss about the theory part also, since I have some time. The IoT networks basically have unique features, which means that e- IoT networks in general, they have unique identification methods, device identification methods, so that each of the device which are connected in the IoT network have their own unique IP address. And therefore, we can uniquely identify each of these devices without any problem. So they will have their own MAC address, they will have their own IP address. Using those addresses and other identities, we can identify the devices involved in the IoT network very uniquely. Uh, we also we also can see that each of the devices have communication modules and sensors to sense some data and transmit that to another device in the coverage area. And then also the network IoT network is able to process the data in their local sensor based embedded system, or they can send the data to a central processor and ask the central processor to do all the computations. So the embedded system at the device level can also do processing, which is known as distributed processing, or else the data can be collected at a central location and the data can be processed in that central location in a centralized manner. When we talk about IoT, uh, we have basically the physical implementation of the IoT network to be done. So when we are physical implementation, when we are doing that implementation, we can divide the implementation as either physical components and physical components that are required, and also the network protocols that are required. So the physical components that are required include the hardware, and what are the hardware components we need. And the network protocols refer to the protocols or the standard procedures that we need to follow to communicate, to enable the communication between the IoT devices. So when we are designing an IoT network, we need to decide what hardware we are using for the IoT network and what are the protocols we are using. Basically, the hardware that we are using consists of, hardware that we are using basically are known as things. The hardware basically is known as things. So Internet of Things means connecting them together. So things refer to the sensors, the processors, communication modules that are used for the IoT network, that are used as hardware for the IoT network. We can consider sensors, processors, communication modules as IoT things and things in the IoT. So as for protocols, we have different protocols that will be used, such as physical layer protocol, link layer, network layer, transport layer, application layer protocols. So we will discuss about these things and protocols, in sequence. Right? So things are actually physical devices that can be that are used to create the IoT network, the physical devices which are IoT devices, and these IoT devices have these hardware components. These hardware components are basically referred to the things in IoT. So they comprise of sensors and basically processing boards that are used. Also, the sensors, the things can be either simple sensors or they could be complex machines and systems. So when we look at the phones, right, the phones are full of sensors, and it has also the communication modules. So when we talk about the sensors that are included in the phone, there are multiple amount of sensors included in a phone. When we talk about the latest smartphones, the smartphones have multiple sensors which are useful for different tasks, various tasks. Near field communication is NFC, and it is used for communicating within a short range. Proximity sensor, we can detect the proximity to an object using proximity sensors. So likewise, we have different types of sensors: accelerometers, magnetometers, humidity sensors, gyroscopes, moisture sensors, microphones, fingerprint sensors. So barometric pressure sensors, thermometers, touch screens, light sensors, GPS, pedometers, and cameras, and so on. So these different types of sensors are available in the latest phones. So the sensors which we normally, use in our circuit level, in our circuits, basically are these kind of sensors. We can buy them from market, and we can implement our own circuits using these sensors. So these sensors are basically light dependent resistors. So they can detect the light sensitivity, and based on the light sensitivity, the resistance of this resistor will change. Based on the sensitivity of the light, the resistance will change. So the resistance will either increase or decrease based on the light sensitivity. If we take the passive infrared sensor, it detects IR radiation and it is used for applications of identifying animals, humans in the environment. So IR radiation can be used to identify whether there's some warmth in the environment. IR means like warmth measuring waves, heat waves. IR means heat waves, so infrared waves. Heat waves can be sensed from this sensor. It is used for identifying human presence or animal presence in the environment. So smoke sensor is used for identifying smoke in the area. So if there's some kind of a fire, you can you detect that using the smoke sensor. Temperature and humidity sensor. Temperature and humidity sensor are sensors that can measure temperature and the humidity levels. And this is one of the sensors that can be used to measure that. Ultrasonic sensor is another sensor which can be used. Ultrasonic, which can be used to measure the distance to a nearby object using the ultrasonic sound waves. So we have other sensors that are in place which are popularly used. So sensors such as gyroscope sensors, which enables in a phone, the gyroscope sensor is used to identify the orientation of the device along a certain direction. So the orientation of the phone can be measured using the gyroscopes. And other sensors are also included there, which enables us to understand the orientation of the phone. Current sensing module is in here, so current measurement can be done through this sensor. We can easily read the current by connecting this module to a circuit, and then we can easily read the value of the current through this using this microcontroller. I'm using this sensor. So sensor. And also we have this Hall effect sensor, where we have this 3-pin sensor. This Hall effect sensor is used to measure the magnetic field around a certain specific environment where this sensor is. So if there's high magnetic field, it will give a certain voltage. If there's low magnetic field, then it will have another, voltage range. So based on the drastic difference in the voltage output, we are able to state that some magnetic field change has occurred in the environment, and that some kind of magnetic field variation has happened. A drastic variation has happened. Earlier I talked about sensors which fall under passive category, passive sensors. So passive and active sensors, there are 2 types. So passive sensors are basically sensors that require an external power supply, right? So these sensors are sensors which require external power supply. And when you take the active sensors, they don't require an external power supply. We can get an output from the sensor once we give a certain input. So one such example is thermocouple. Thermocouple is one example, and it takes temperature as input and gives an output voltage as the output. And based on the output voltage, the output, whatever the system functions on. So the thermocouple is an active sensor. So when we so that is basically regarding sensors. So we did not cover all the sensors that are available. There are many types of sensors available in the Sri Lanka and in other countries in the market. You can test them out if you have the ability. So we need to, we can use them for different applications. So the next component that we want to look at is the hardware microcontroller boards. The hardware microcontroller boards are basically the controllers, the boards which has the specific microcontrollers. So popular microcontrollers are basically Arduino, Node MCU, Raspberry Pi, ESP32, and so on. So popular ones means like most popular one could be Arduino still, because of its easiness to use for a beginner. Also ESP32 is also becoming very popular. So the components that we can observe in a hardware controller board is basically power supply, communication, processing, storage, input, output, and etc. So basically we have processing units, communication units, power supply units. Then afterwards we also have the storage, input, output pins. So those features are enabled in a certain microcontroller. So there are several microcontrollers that are in use. So we'll just go roughly through them. Basically, Arduino is one of the most popular microcontroller boards. Node MCU is, one of the disadvantages of Arduino is that the memory is less. So the memory is less. Therefore, the amount of data that we can store in this board is less. Because of that, if you are doing like data intensive tasks, then you might not be able to store all the data in the Arduino. So then we have to go for other options. And we have to go for options where we can store a lot of data. So Node MCU is actually like a microcontroller which is in the family of ESP32. However, this controller is a model that came before ESP32, and it has been it also has some functions that are interesting when you compare with the ESP32. It has low cost. It's a low cost microcontroller, and it is easy to code. It has Wi-Fi connectivity, and it has dual core. Dual core means like you can do simultaneously processing. Uh, I mean, you using both the cores, you can do processing much more faster than a single core. ESP32 is a like a what do you call, like a microcontroller that came after Node MCU. So in the ESP32, we have dual core processor, means two processors to do the processing, two cores to do the processing instead of one. We have Wi-Fi connectivity, Bluetooth connectivity. I mean, Bluetooth and Bluetooth low energy connectivities. And also it has more input pins or output pins than the other, I mean, Node MCU controller board. It has Hall effect sensors in place and built-in temperature sensors and built-in touch sensors, as we discussed. When we talk about the Raspberry Pi has more functions than those other boards that we discussed about. It has, so Raspberry Pi is a very complex and advanced microcontroller and is used for very high data intensive tasks such as like artificial intelligence development, machine learning development, image processing, and so on. So whatever the situation where there's a lot of processing to do and data storage, then Raspberry Pi is a good option for such kind of applications. Also, it has a very high clock speed of about 1.2 megahertz, and that speed is sufficient considerably to do the data rate, to achieve the necessary data rates. It has multiple interfaces which allow the input signals to be directly connected to the Raspberry Pi board without any difficulty. We have HDMI ports, USB, Ethernet, onboard Wi-Fi, and Bluetooth functions, Bluetooth connectivity pins and modules. So most of the input port types are enabled in this Raspberry Pi. When we are developing the code in the Raspberry Pi, we can develop it using Python or other C++ languages. It also supports Linux. So it is very, I think, a programmable microcontroller board. So those are the microcontroller boards which are very popular. However, like there are other microcontroller boards also in the market, which are also used for different tasks. And such kind of boards are the ones that we are using in the industry. In the industry, we are using separate set of the microcontroller boards. So about those industrial boards, we will talk in the industrial IoT lecture as well. So I can show you the images of such boards also. So industrial IoT systems have sensors that are given in this figure, in this slide. The sensors are higher, I mean, in size. It's larger in size, different sensors are there for example, vibration measurement, distance measurement, temperature measurements, RFID module integrated sensors, and those sensors are very robust and large in size. And they are, when we compare with the normal temperature sensors, these sensors that are used in the industry are more durable, can be used for a long time. So the air quality monitoring sensors are there, flow monitoring sensors are there, and temperature monitoring sensors are also there. So these sensors are very specifically built for the industrial environment, and we cannot directly use in other applications. So these are very robust and specifically defined for applications. Then we also have the microcontroller boards that are used for the industrial IoT. So the Arduino also has an industrial version, and Arduino has enabled industries to integrate the Arduino board into their work into their processes. So this Arduino Industrial 1.1 is more durable and more robust than the common Arduino that we are using for our basic programming and etc. We also have now in here we have PLC, which has the Arduino microcontroller embedded in it, and which allows us to do the processing in this whatever the PLC, and allow us to do the processing in the PLC using also the assistance of the Arduino. So rather than using so we can use the Arduino programming to do the processes in the PLC. We also can use Raspberry Pi to enable human touch interfaces and get the work done using the Raspberry Pi. So it's another application of the Raspberry Pis and how they are implemented in the industry. So this is a picture of how the sensors are connected to the processing unit. So sensors are connected by wires to a processing unit. The processing unit will forward or relay that data to a certain cloud server. So that is basically how the connection has happened. So basically sensors need to be connected to the processing unit. Processing unit will transmit the data to the necessary destination through a certain other medium. So that is basically regarding the industrial IoT modules. And also, like, since I came to this slide, I will tell that the mark allocation breakdown for this module is such that the assignments will take 10% of the final mark. The mid exam, which is actually the group project, will constitute 20% of the final mark. Then the end exam will take 70% of the final grade. So most of the marks will be allocated from the end exam. However, like, group project plays a significant role in deciding your grade. So therefore, group project must be done in a considerably satisfactory level, and it determines all the final grades. So the project details are given in the LMS, and using those data, you can start doing the project. So basically, that is regarding the IoT hardware and what are the basic hardware components we normally use for IoT networks. So we when we discussed about this up to this point. So currently we are at this stage where we discuss about the protocols that are used in IoT networks. So in general, there are mainly 5 layers under which we are discussing the protocols. So the layers are physical layer, data link layer, network layer, transport layer, application layer. So these protocols are basically are a set of standards or rules that define how the data will be transmitted over the physical layer or the medium. So a protocol is something that defines the standard of transmitting the data, right? So according to that standard only, the data is transmitted. So without a standard, it's difficult to transmit the data over the wide internet, over the wide area network. So have you learned about these protocols before? What are the protocols that you have learned so far? Ratnayaka, are you here? Can you let me know like what are the protocols that you have heard about and then you have learned? Are you here? All right. So I will continue. So the protocols such as I think protocols which are popularly used in computer networks are also used in IoT networks. So for example, HTTP and other TCP, UDP protocols, IPv4, IPv6 protocols. These are also used in IoT systems. Apart from that, like based on the IoT application, the communication protocols such as ZigBee, Bluetooth, low energy, Wi-Fi, LoRa, NFC, cellular, they will be used in the physical layer. So they will be used which fall under the physical layer. So they will define the physical layer standards for transmitting the data over that physical layer medium. So depending on the communication required, they will in the IoT network designer will select the best communication protocol for that application. And network layer protocols, I think IPv4, IPv6 are very popular protocols that are used in general. Apart from that, 6LoWPAN protocol is one of the protocols that are used uniquely for low power, resource constrained environments, which are widely seen with the IoT networks. So TCP, UDP are basically the transport layer protocols that are used in standard for any communication network or computer networks. So those two remain. And the application layer protocols, there are protocols that are specific to IoT applications such as MQTT, COAP, likewise. So those are basically the overview of the protocols that are basically used. And this figure shows the IoT protocol stack, which contains all the protocols under each layer that is basically considered. So I think I will discuss about these protocols maybe in the next class. I think I have covered sufficient amount of uh, uh, I mean content for today's lecture. I will stop in this point.